Good afternoon, Mumbai. So I stand here between the lunch, and I promise I won't take too long. So earlier speakers here talked about Indian chemical industry is becoming global. It's becoming relevant, and for this industry to continue to prosper, it has to remain top-notch quality, lowest possible cost. And so we're going to talk about how do we make this industry more efficient than what it is today. So if you look at any chemical manufacturing process, it's a combination of certain batch processes or continuous processes or even a combination. And these are typically designed to start from a particular raw material, go through the processing under certain process conditions to achieve a product quality that meets the requirements of the end user. And we heard a lot today also about changing scenarios, people trying to produce more, requirements of quality being changed. And when that happens, production processes are altered. Production processes are optimized. And then when these processes change, over a time, there is an opportunity to bring back that process to the optimum point. And this could be related with the yield, could be cost, could be quality, or even in some cases, environmental impact. So if we were to then look at, dial down this into what are we talking about? We are talking about how do we optimize any process. So if you look at any process, you have raw materials, you have process and equipment, and you have people, that is the operational team that is operating. And to drive efficiency, you have to have, first of all, a visualization. You should be able to see what's going on in the process. Because if once you have the visualization, then you will be able to take necessary action to stabilize it and then optimize it. Fluctuations in raw material, different behaviors of the operational teams, and complex processes leads to fluctuations. And to be sure to meet the required target quality, it's important that we keep minimum possible distance between what's the basic minimum requirement. And that safety margin actually also determines your cost. The tighter this gap is, the more money you make. So the first step to drive efficiency is to able to visualize the fluctuations. The second step is then to stabilize it and then optimize it. This then brings down to how this is perceived. So in controls world, it's we call it the control hierarchy. At the foundation levels, you have got the eyes to process, the measurements, the process measurements. So simple things like pressure, temperature, pH, those are the very simple process indicators of how process is working. And these process measurement must be relevant, must be accurate, must be repeatable. Then only you'll be able to use it for any controls. And that comes to the second layer. So as the number of variables increases, the DCS level controls, which is the primarily utilized for any batch process or a continuous process, as the number of variables increase and as you have more dead times, that's when the DCS level controls don't work very well. And that's when the model predictive controls, advanced process controls kick in, which then allows the operations to meet the requirement. So you have got a static raw material and the finished goods, but then you have other processes like utilities. You need steam, you need power. How do we manage between the different unit operations so that you operate at the most optimum? And that's when you you talk about the top layer, which is the business optimization. So on the measurement layer, what is relevant from our business is a technology that we acquired a few years ago called Fitner. It's an NIR-based technology which can measure chemical concentrations in liquid streams. It was developed by a US company called Fitner, and so we acquired that business. On the second layer, we don't have DCSs, but we have got some complementary tools that can help improve the performance of your DCS level. So there are two tools that we are going to talk about today. One is the data park and another is the control suite. And then the next one is the multivariate advanced control system, what we call as APC. So today we will discuss those tools. So the first tool that we're going to talk about is called Data Park. So Data Park is a data management tool that can seamlessly connect with different data sources. So you have got IT systems and OT systems. So a lot of data is being generated by different operations. But if that data is not utilized for any meaningful control, then we don't harness that value. And while there are a lot of historians in the market where Data Park has been a development that was done by chemical engineers. So it was developed as a tool by the chemical engineers in US, and it was based on their experiences of the professional challenges that they faced in running those chemical plants. And so it's a more user-friendly data management toolbox that allows different levels of users. So there could be operators, shift engineers, managers, production managers, management offices. Everybody can see that their set of data in their form, in their format. And the most important thing is how do we provide that data visualization, analytical capability to different users level at the speed of the thought. And because when you get that data quickly, that's when they can take decisions. And those fast decisions is where you make the money. You make the process more easier. So seamless data connectivity with different data sources is the key feature of this tool. So a quick snapshot of this. We have got rich loaded functionalities and a plethora of standard applications. This tool is highly customizable, and that answers the business need of the industry. So I won't bore you with all the features. We have a lot of information that is available to you, but the key idea here is this tool is trying to make the operators become engineers so that they can focus on improving the process. And then because when you empower them with the tool that can help them troubleshoot with the process, that's when you make more money. So here are some of the case histories for this data park. So data park is implemented by this company called Specialty Chemical Corporation. This is a combination of batch and continuous process and lots of recipes with manual interventions, which made it difficult for the operations to keep the manual record and then sharing of that data for analysis and improvements. So our free form of manual data entry allowed them to overcome this challenge, and since then they have been using this tool continuously. The second case history is about S-Oil. It's a very large multi-site business in oil refineries, lubes, petrochemicals, and olefins in Asia Pacific. And they were using the legacy PI systems connecting with dozens of data sources. And so when they switched over to our tool, they were able to migrate first of all, the migration was very swift, and then they were able to connect with all the data sources, and the user-friendly tools allowed them to retrieve the data in a much faster way and then taking the decision. The second tool is what we call as control suite. So it's a loop monitoring software. It can seamlessly connect with different DCS makes, and it provides a bird's eye view of how the different loops within a unit operation or on a site, on multiple sites are performing. And this then allows different, again, users, so production people can see how are their underlying loops performing, whether the loops have got issues, mechanical issues, whether it has got a valve which is sticking, or if the loop is not tuned very well. So that basically the USP for this tool is that it is independent of the DCS make, and it provides a prioritization tool for people to work on different loops and improve the variations. Because if these underlying loops don't work very well, then any kind of control that you build on top of it doesn't work very well. So what is really nice is it provides kind of a box, a loop performance chart, which shows the performance of each loop, and you can create reports, alarms, and you can then dissect from the reports what's wrong with the individual loop and fix it. One of the largest, biggest adopters, or the earliest adopter of this tool was Dow Chemical. So Dow uses this tool across all their global sites, and they have global SMEs that look at each of their plants, and they provide the individual plants with share the best practices and also a tool towards continuous improvement. The third tool that we are going to talk about is advanced process control. So the question is, why do we need advanced process controls? So if you look at this data set, you can see that there is some data which has got different colors. So if you look at it, you would say, well, this looks normal, right? How about if we look at it from a different perspective? You start to see that there is some difference between the two data sets. But how about this? If you add one more dimension to it, and now you can see that actually these two data sets are quite different. So the point I'm trying to make here is, human brain can think only in two dimensions. And that's what happens when you are running a plant, a process. If you can't, and you are trying to control a lot of variables. So if you have a process which has got many variables, and you have got feed-forward disturbances, that's when the regular DCS level controls don't work very well. And this is where the MPCs have proven expertise. MPCs have been around in the industry for more than 3 decades. Oil and gas has been using it for more than 3 decades. So it has been a proven tool that has been used in the chemical industry. And so what we have is a tool, what we call as MAX. MAX stands for Multivariate Advanced Control System. It's, while there are many other APCs available, but what we think is really unique about this is it's an open structure, open architecture, and a Windows-based tool, which then allows all the operators, all the operations people to understand what's going on in the controls. So if a model predictive control is asking to shift the performance to a different level, they can actually see why it is doing what it is doing. So you connect the system with the DCS via OPC, and then the server does all the maths and then writes back the set points back to the DCS for the process to run as closest as possible to its optimum design. And this is a snapshot of a control matrix from a refinery, which shows typical CVs and MVs here. Case history here, so one of our key users of this Mac software has been Linde Gas. So Linde were one of the earliest adopters of the Mac software, And now they use it in every plant around the world. They have a regional operating center in Kuala Lumpur, and that's where many of their SMEs for unit operations sit, which then coordinate with different plants around, to how to optimize it. And so there's a lot of information available about this case history. Some more examples of MACs in the chemical industry and the refining industry involving acids, crude oil, gas, polymer, and so on. And here is a partial laundry list of our global customer base who have confided in our technologies. And as you can see, there are dozens of chemical manufacturing plants, but also ethanol, mining, oil and gas, food and beverage, and also pulp and paper. So we believe that optimization is a continuous journey. For some operations, it could be just building foundational layers. It could be just improving and making sure that their DCS level controls are working well. Ultimately, to have a two-way communication between the man and the machine. For others, it could be building advanced layers on top of their existing infrastructure to how to improve their quality, how to reduce their cost. So traversing this journey of digitalization, and that too a profitable digitalization in phases, selecting the right unit operations, implementing a grounded plan, and then having the right organization capability is critical. So choosing the right partners who can handhold, who can guide you through the process of how do you implement it, do you have the right tools, do you have the right mindset, and you have the experience on the ground. That's what we believe is increases the chance of success. So that's all I wanted to share. We are here just outside this hall. Catch us if you want to have a very specific discussion about your processes. Thank you.